Here is a quick video to help you guys if you're having trouble submitting answers or understanding the 1.3 estimating limits graphically DeltaMath assignments. So I'm just going to go through and probably do 2 examples of each of the types of questions that you'll see. And if you have any questions after that, please let me know. So I'm going to click on first finding limits graphically one-sided, and then I'm just going to work through a couple of problems. So for the function f of x shown below, determine the limit of f of x as x approaches 4 from the left-hand side. So I'm approaching this x value of 4 right here, and I'm going to do it from the left-hand side. So I'm just going to follow my graph. And as I get closer and closer to an x value of 4, what does my y value look like it's going to be? So as I approach 4 from the left-hand side, it looks like my y value is going to be -6. Even though there's not a dot there, it just looks like as I get really, really close to an x value of 4, my y value looks like it'll be a -6. So I'm going to type in a -6 there, submit my answer. Yay! All right, and then it goes through the actual process as well. So if you didn't quite understand my description, you can go ahead and read this, and it's kind of doing a visual for you as well. I'm going to do another problem. So in this one, it says, for the function f of x shown below, determine the limit of f of x as x approaches 4 from the right-hand side. So here's my x value of 4, and as I approach from the right-hand side, I just got this little part of a graph that I'll be following here, but I'll be following it up, getting closer and closer to 4 from the right-hand side. It looks like my y value is again -6. That's just a coincidence, though. So I'll go ahead and do that. Hooray! So that's what the y values, that's what the first section is going to look like, finding one-sided limits. Again, you'll notice they'll give you a kind of description and then also a visual of what I sort of did. As I approach 4 from the right-hand side, it looks like my y value will be -6. All right, let's go ahead and we'll try finding limits graphically, type 1. So this one says, answer all of the questions below about the function f of x graphed below when x equals 5. And so we're basically finding the left-hand limit, the right-hand limit, the general limit, and then the actual function at 5. So if I look at my x value of 5, if I do my left-hand limit first, so as I approach 5 from the left-hand side, it looks like my y value will be 1. As I approach 5 from the right-hand side, it looks like my y value will be 1. My general limit, since these two match, is going to be 1. And then my actual function, f of 5, is where the actual dot is on 5, or where the actual point is. And so my actual point is right here, which is at 2. Voila. And they'll go through and do examples of each of those ones. Again, you can watch it visually if you would like. Let's go ahead and do one more of these. So now we're doing the same thing, answer all the questions below about this function when x equals 2. So as I approach 2, here's my x value of 2. As I approach 2 from the left-hand side, it looks like my y value will be 5. As I approach 2 from the right-hand side, it looks like my y value will be 3. And since those don't match, I can go ahead and click in here and I can put in D and E. It has a nice button there for me to do that because those are not the same number, so my general limit does not exist. And then f of 2, where is my actual point or dot at 2? Well, that is at a y value of 3. There we go. All right, let's go ahead and find limits graphically with type 2 problem. So this one, it looks like I'm doing this similar thing, but I'm only answering one limit, or I'm only finding one limit. So this should be a little bit easier. Use the graph of the function shown below in order to determine the limit of f of x as x approaches -5 from the left-hand side. So here's -5, and then I'm going to follow my graph as I get really close to -5 from the left-hand side. It looks like my y value is going to be -6. Nice. And then I'll do one more of these. Again, they'll do the visual for you. All right. So this one, use a graph of the function f of x shown below in order to determine the limit of f of x as x approaches negative 5 from the left-hand side. So as I get closer to negative 5 from the left-hand side, what does my y value look like it's going to be? It looks like it's going to be negative 6. I've had a lot of those in this video. There you go. And last but not least, we're going to talk about the reverse. So finding limits graphically, but you guys are going to be asked to do a slightly different task with it. So in this problem, it says use the graph of the function f of x shown below in order to determine all the values for which your limit of your function equals 0. So it's trying to tell you to fill in what a would be so that as x approached that particular value, your y value looks like it would be 0. So for example, if I'm looking around my graph, there's a couple of different places where I would be hitting 0, but it has to be the general limit. So for example, at negative 6, as x approaches negative 6, my left-hand limit is 0, but as x approaches negative 6 from the right-hand side, my limit is not 0. So I would not be able to submit negative 6 in here and get it correct. Instead, I'm going to look at other places where it seems my graph hits 0, but from the left and the right-hand side. That doesn't happen at negative 6. So let's see. If I keep following my graph, all right, I'm approaching 0, or excuse me, as my x value approaches negative 3, my function seems to hit 0. That's from the left-hand side and from the right-hand side, so negative 3 would be an option. And then as I approach, let's see, that's not 0, that's not 0. 1 is 0, but only from the right-hand side. So as my function approaches 1 from the right-hand side, I get 0, but from the left-hand side, I do not, so that doesn't count. So I think actually just negative 3 is my only answer. So I'm going to go ahead and submit. Here we go. That's the only place that where my left-hand limit and my right-hand limit both equal 0 as my x value approaches any of these numbers. All right, let's do one more. This one's a little bit tricky, so maybe I'll do 3 of them. So this one says the same thing. So it wants me to figure out where my limit of my function would be equal to 0. So where both my left and my right hand side of my limits would actually equal 0. So I'm following my graph. All right. As I approach negative 6, I get 0 from the left hand side. And as I approach negative 6 from the right hand side, I also get 0. So that's an option. Then it goes down, 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 comes back up, doesn't quite hit 0, goes down, goes down, goes down. Oh, this one's a little bit tricky because even though my actual dot is at 0, my limit is what my graph seems to be approaching. So at x equals 1, my graph seems to be approaching a y value from negative 3 from both the left and right hand sides. And so my limit wouldn't be 0 here. My limit would be negative 3. Only the actual point would be 0. So be careful about that one. Nope, I don't think, because this doesn't hit 0. That does come from 0, but doesn't hit 0 down here. So I think that's the only place, again, where my general limit would equal 0. Yep. All right, let's try one more. All right, so now we're looking at a different number. So it says use the graph of the function f of x shown below in order to determine all the values of a for which the limit would be negative 2. So I have to figure out where my graph seems to approach negative 2 from both the left and right hand side. So definitely not negative 2, definitely not negative 2, definitely. Okay. I'm getting close to negative 2 right here. So as my x value approaches negative 6 from the left-hand side, my y value seems to be negative 2. And the same thing happens when I come from the right-hand side too. So negative 6 would be an option because my limit as x approaches negative 6 would be negative 2. Right here, this got this jump, so my limit doesn't exist, right? Because even though my right hand comes down to negative 2, this goes way farther down. This one, again, is just an actual point at negative 2. My graph doesn't approach that point in any way. Too high, too high. Oh, here we go. Here's another place where my graph from the left-hand side approaches a y value of negative 2, and then again from the right-hand side. And so as my x value approaches 2, that would also work. My limit would be negative 2. This one doesn't count because, again, it's got that jump. Oh, and then we got one more spot right here. So as I approach 8 from the left-hand side and from the right-hand side, my graph seems to be -2, and so 8 would also work. Those would be the 3 places that if I plug them in for A up here, this would be a true statement. There we go. And again, it gives you that kind of visual. So just that little section where that works. All right, let me know if you have any questions.